All right, welcome back to Math 103 College Algebra. This is from Central Connecticut State University. Today we're going to look at the division of polynomials. How do I divide polynomials? We're going to start by looking at monomials first. Remember, a monomial is a single term polynomial, and we're not dividing excuse me. All right, welcome back to Math 103 College Algebra. This is for Central Connecticut State University. Today in this video, we're going to look at the division of polynomials. We're dividing polynomials. First, we're going to divide by a monomial. We're going to divide by a single term denominator. Okay? To divide by a monomial, you simply divide each term of the polynomial by the monomial separately. So for example, number 1, we want to divide 6x cubed minus 3x squared plus 2 by 2x. What that looks like is the same as if I have 6x to the third minus 3x squared plus 2 all being divided by 2x. Okay? So what I can do is I can divide each term separately. I have the 6x cubed is being divided by 2x minus, then I have the 3x squared is being divided by 2x, and then I have 2 being divided by 2x. And I can handle those three things separately. First of all, I have 6 divided by 2, and then I have x cubed divided by x. Okay, let me put that x back in the denominator. So 6 divided by 2 is 3. And then x cubed divided by x is x squared. Then I have minus 3 divided by 2 is 3 over 2. That's not going to divide. And then we have x squared divided by x is just a single x. So I have 3x over 2. Then finally, I have 2 divided by 2 over x. 2 divided by 2 is 1, and the x remains in the denominator. And that is dividing by a monomial. And we're good there. We're welcome to stop there. Number 2, 4x to the fourth plus 9x to the third minus 5x plus 6. We're going to divide all of that by 3x squared. Again, that's the same as dividing each individual term by the 3x squared. And then I'm going to go back and do each individually. So notice, first of all, 4 divided by 3 isn't going to reduce. I'm going to leave it 4 divided by 3. X to the fourth divided by x squared is x squared. Next, we have 9 divided by 3 is 3. I'm not going to need this fraction because 9 divided by 3 is 3. X to the third divided by x squared is just x. Next fraction, 5 divided by 3 does not simplify. And then we have x divided by x squared. That's just going to leave me x in the denominator. And then finally, 6 divided by 3 is 2. And we just have the x squared in the denominator. And we are divided. Okay? To divide by polynomials, there's actually two processes that we can use. There's long division and then there's synthetic division. First, I'm going to use long division. Just a quick review. If I want to divide 2378 by 15, we have 15 outside the division. Okay, I don't need all of that. 15 goes into 23 once. 1 times 15 is 15, and then we subtract 15 from the 23. 23 minus 15 is 8, and then we bring down the 7. 15 goes in 87 5 times because 5 times 15 is 75. We subtract the 75. 87 minus 75 is 12. We bring down the 8. 15 goes into 128 8 times because 8 times 15 is 120. Again, we subtract and we get 8. So we have 158 with a remainder of 8, or 158 and 8/15, because it still remains to divide the 8 by the 15. Okay, so if I'm going to use a similar process here, for number 4, x minus 3, I'm going to divide that into the 2x cubed minus 3x squared minus 11x plus 7. So first I'm going to do 2x cubed divided by x. 2x cubed divided by x is 2x squared. Then I'm going to do the 2x squared times the x minus 3 is 2x cubed minus 6x squared. And just like the long division over here to the left of number 3, I'm then going to subtract that. 2x to the third minus 2x to the third, these will cancel. Then I have negative 3x squared minus negative 6x squared is a positive 3x squared. Bring down the 11x. 3x squared divided by x is 3x. So this is plus 3x, because now when I do 3x times the x minus 3, I have 3x squared minus 9x. And again, I subtract, just like in the process over here to the left for long division. 3x squared minus 3x squared cancels. Negative 11x minus negative 9x is a negative 2x plus 7. Negative 2x divided by x is negative 2. And again, we multiply that negative 2 times the x minus 3. We have negative 2x plus 6. We subtract one more time. Negative 2x minus negative 2x cancels. 7 minus 6 is 1. So we get 2x squared plus 3x minus 2 with a remainder of 1. 2x squared plus 3x minus 2 is our quotient. 1 is our remainder. I can also write this as 2x squared plus 3x minus 2 plus 1 over x minus 3, because that division remains to be done. Okay, so let's look at number 5 here. We're going to divide 3x to the third minus 3x squared minus 2x minus 4. We're going to divide that by x plus 2. So 3x to the third divided by x is 3x squared. And again, we're going to multiply the 3x squared times the x plus 2 is going to give me a 3x to the third minus 6x squared plus 6x squared. Almost made that mistake. So now when we subtract, 3x to the third minus 3x to the third is going to cancel. Negative 3x squared minus 6x is a negative 9x squared. Bring down the negative 2x. Negative 9x divided by x is a negative 9x. We multiply the negative 9x times the x plus 2, and we're going to get a negative 9x squared minus 18x. And again, we're going to subtract. If it's helpful for you, you can certainly distribute that negative inside, and then notice that the negative 9x squared and a 9x squared are going to cancel. Negative 2x plus 18x is a 16x. Bring down the minus 4 plus 16. 16 times x plus 2 is 16x plus 32. And again, we're going to subtract that. 16x minus 16x is going to cancel. Negative 4 minus 32 is a negative 36. So that negative 36 is my remainder. So our quotient, again, is 3x squared minus 9x plus 16. And then we have a remainder. So I could write minus 36 or plus negative 36 over x plus 2. Either way. Okay, so let's go ahead and look at number 6. You'll notice that for number 6, we have a coefficient on the x in the denominator. So 2x plus 3 goes into the 6x squared plus 5x minus 10. 6x squared divided by 2x is 3x. 3x times 2x is 6x squared. 3x times the 3 is 9x. And then we're going to subtract that. So 6x squared minus 6x squared is going to cancel. 5x minus 9x is a negative 4x minus 10. Then we multiply by the negative 2. Negative 2 times 2x plus 3 is a negative 4x minus 6. When we subtract, 4x minus negative 4x is going to cancel. This is plus a positive, so we're going to get negative 4. So our remainder is negative 4. So our quotient is 3x minus 2. And we have a remainder of negative 4 to be divided by the 2x plus 3. Okay? I'm going to skip number 7 since it's a bit redundant. Okay? In number 8, I want to be sure to do that for 2 reasons here. First of all, notice that we're dividing by x squared plus 2. So we have a quadratic there, x squared. Also notice we have 3x to the third minus 2x squared, but there is no x term. There's no linear term. You have to write 0x. You need that placeholder. Okay, so x squared goes into 3x squared 3x times. 3x times the x squared plus 2 is 3x cubed plus 6x. And then we're going to subtract that. So 3x to the third minus 3x to the third cancels. We have negative 2x squared minus nothing, so that's a negative 2x squared. 0x minus 6x is a negative 6x. Bring down the plus 4. Then we have negative 2x squared divided by x squared is negative 2. So we have negative 2x squared minus 4. So we have negative 2x squared minus the negative 2x squared cancels. Negative 6x minus nothing is negative 6x. And then 4 minus the negative 4 is a positive 8. And that's as far as I can go. My remainder is the negative 6x plus 8. So again, we have a quotient of 3x minus 2 plus a remainder of negative 6x plus 8 over x squared plus 2. And that's our division problem. Okay, so now I want to look at synthetic division. There's an algorithm called synthetic division. However, an upside of synthetic division is that it takes less work. You'll see that in a moment. However, it only works if I'm dividing by a linear factor. What I mean by a linear factor is x plus 3, x plus 2, x minus 2. Number 12, dividing by the 2x plus 3, that's a little tricky. Okay? X minus 3, I'm dividing by that, so I need a 3 in this little box. And then my coefficients are 2, negative 3, negative 11, and 7. Notice I only need the coefficients. I'm going to leave a little space or a horizontal line, and then a vertical line between the negative 11 and the 7. I bring down the 2. 2 times 3 is 6. Negative 3 plus 6 is 3. So you'll notice what I did is you just bring down the 2, then 2 times 3 is 6. And then I add, coming down, negative 3 plus 6 is 3. Again, I'm going to multiply. 3 times 3 is 9, and I'm going to write that over here as 9. Negative 11 plus 9 is negative 2. Negative 2 times the 3 is a negative 6. 7 plus 6 is 1. So 1 is my remainder. Negative 2 is my constant. 3 is my linear term. 2 is my quadratic term. So I have 2x squared plus 3x minus 2 plus a remainder of 1 yet to be divided by the x minus 3. Okay, so let's look at another one. Number 10, 3x to the third minus 3x squared minus 2x minus 4. My coefficients are 3, negative 2, negative 4. I'm dividing by x plus 2, so the negative 2 is what goes in that box. Horizontal line with a little space, vertical line between the negative 2 and negative 4. Break down the 3. 3 times negative 2 is negative 6. Negative 3 and negative 6 is a negative 9. Negative 9 times the negative 2 is a positive 18. Negative 2 plus 18 is 16. 16 times negative 2 is negative 32. Negative 4 and negative 32 is a negative 36. So my quotient is 3x squared minus 9x plus 16 with a remainder of negative 36 yet to be divided by the x plus 2. Now if you recognize these problems, number 9 and number 10, they should be the same as the long divisions, number 4 and number 5. So we're getting the same solution, the same quotient remainder for each of those, but there's a lot less work that we need to do for those. Let's do number 11. Okay. Number 11, 2, 4, negative 1, and 5 are my coefficients. We're dividing by x minus 2, so 2 goes in the box. Bring down the 2. 2 times 2 is 4. 4 plus 4 is 8. 8 times the 2 is 16. 16 minus 1 is 15. 15 times the 2 is 30. Adding the 5 and the 30 is 35. 2x squared plus 8x plus 15 plus 35 is my remainder over x minus 2. Process goes more quickly. So number 12, let's talk about this thing with the denominator having a linear term, but the leading coefficient is 2, not 1. I'm really going to need to make this the same as 6x squared plus 5x minus 10 divided by 2 and x plus 3 halves. Okay, so my coefficients are 6, 5, negative 10. First, I'm going to divide by the x plus 3 halves. So what's going to go in this box is the negative 3 halves. 6 comes down. 6 times negative 3 halves is a negative 9. 5 minus 9 is a negative 4. Negative 4 times the negative 3 halves is 6. Negative 10 plus 6 is negative 4. However, that's only dividing by the x plus 3 halves. I also need to divide by the 2. So everything still gets divided by the 2. So I have 3, negative 2, negative 2. So my quotient is 3x minus 2 minus, actually, you know what? Back up. I did not need to divide this by the negative 2, so I'm going to leave that negative 4 because I have this got divided by the 2, so that's 3x minus 2. I still have the negative 4 that needs to be divided by both the 2 and the x plus 3 halves. So quotient and remainder. Okay. So one last thing I want to show you, what's called the remainder theorem. I'm not going to do this repetitively, but what I want to do is let's just take number 9, okay? So number 9, I'm sorry, I'm going to scroll up back and forth here. I didn't write it down. I have 2x to the third minus 3x squared minus 11x plus 7. Notice that when we divided that by the x minus 3, we got a remainder of 1. If I let f of x equal the 2x to the third minus 3x squared minus 11x plus 7, see the x minus 3? If I do f of 3, 2, times 3 cubed minus 3 times 3 squared minus 11 times 3 plus 7. So I'm putting the 3 in place of the x. Whatever it was that I put in the box here, put that in for f of x. 3 cubed is 27, times 2 is 54. 3 squared is 9, times 3 is 27. 11 times 3 is 33, plus 7. So I've got 54 plus 7 is 61. 27 and 33 is 60. 60 minus 61, I'm sorry, 61 minus 60 is 1. Notice, when I put the 3 in for x, what did we get? We got 1. When we did the division, what was the remainder? That was 1. That will always be true, and that is a remainder theorem. So again, I hope that this was helpful. I hope to see you again soon in class. If you find these videos helpful, please be sure to like or subscribe.